Assalamualaikum and good morning. My name is IRFAN MUSTAQIM bin AHMAD ZAINI, and my three other members, NOR, NABIELLAH, NAELIS binti SHAHRIR, AHMAD HASIF bin NORZLI, and MUHAMAD FARIS bin MOHD NASIR. We are going to present on our project regarding boiler system connecting to temperature sensor. Next slide please. For today's agenda, we have three sections. We have thermistor sensor background study, instrumentation system design, and demonstration. So for thermistor sensor and background studies, NTC thermistor stands for negative temperature coefficient thermistor. NTC thermistor are typically made from metal oxides such as manganese, nickel or cobalt mixed with ceramic material. The temperature range of NTC thermistor sensor is between negative 50 Celsius to 150 Celsius or higher. The sensitivity of this thermistor sensor, they offer high sensitivity, meaning small temperature changes may result in significant resistance variation. For the calibration, due to the non-linear resistance temperature curve, NTC thermistor require calibration to achieve accurate temperature reading. For the application of NTC thermistor sensor, there are many, and one of them are HVAC system, temperature monitoring and control in heating, ventilation, and also air conditioning.
To look into the instrumentation system design. So next slide please. Right, looking forward for this schematic diagram, this circuit begins with a sensor that detects changes in the surrounding temperature. In this case, we can see the sensor measure changes in resistance based on the temperature. Next, once it's measured the temperature, it can convert this measurement into physical quantity such as voltage and also current. Since our project focuses on reading voltage values, we will base our calculation on finding the voltage, so that the sensor has two terminals, which is, and since it is a passive component, it doesn't matter which terminal is connected to ground and which one is to the signal conditioner. In this project, we use a signal conditioner called LM324N, which contains four operational amplifier, or we call as OM. But in this case, we only use two of them. Both OM will be configured an inverting amplifier. The first OM will receive the signal from the sensor and pass it through its negative input pin. Then the output from the first OM will go to the negative input, where the of the second OM and the second OM will provide the final output. Using these two OM allow us to create an instrumentation system with high gain for accurate measurements. Additionally, as the signal passes through this OM, linearization processes will occur to ensure that the output of the sensor is directly proportional to our measurement value. Next.
Okay, based on the circuit layout design, after passing through the signal conditioning system, the data will go to data acquisition unit, which is the DAQ system. So the DAQ system ni will convert the analog signal from the sensor into the digital format. So the data will be used in the coding to perform the calculation and obtain the desired result, namely the voltage and the temperature value. So finally, the last step of the instrumentation is to display the output value obtained from the previous process. In this project, we display the result using LCD. That you can see, we attach the LCD on the middle of the prototype. So from that, we display by LCD and LED. LED will be indicator for macam untuk hot, cool, gitu. So the LCD will display the temperature and the voltage value. LED will indicate whether the measure temperature is warm or hot, with blue LED indicating warm and yellow LED indicate a hot temperature. Next.
So moving into our demonstration of instrumentation design. So this is basically our process on detecting the water during the cold environment. So as you can see, the LED blue color is on, and when the temperature is on, okay, so we start again lah. So as you can see, this is our prototype of the project. As you can see, the light blue is on, and while the sensor of the two pin, which is the NTC thermistor probe, is detecting the temperature, which it display the 41.82 degrees Celsius with voltage of 2.91 volt. Okay, so this is our inside part of our prototype. As you can see, there is a circuit and the Arduino board. So as you can see, we are using the signal conditioner, which is the LM324N type, which consists of 4 OPM, but we only use 2. So as you can see, we also use 5 resistor with 10,000 ohms, and we're using the sensor of 2 pin, which is the NTC thermistor probe, and also the wires which connected to the ground, and also for other pins of sensor is connected to the signal of the signal conditioner. So so this is our LCD and LED. Okay, so this is our coding and also our result on the serial monitor, which also display the temperature and also the voltage. So this is during the process on detecting the hot water. As you can see, the yellow LED is turned on, which indicate the hot temperature, and also the LCD is showing the temperature with 51.10 degrees Celsius and the voltage is 3.72 volt. So this is our circuit and also the Arduino board, and this is our LCD. Okay. So as you can see, our LCD is connecting to the I2C module. And this is the LED. You only use 2 LEDs, which is the blue color and yellow color. Okay, so this is the circuit. Okay, and so this is the board, the Arduino board. So as you can see, the LCD pin, which is the SDA and SCL pin is connected to Arduino board. And also the pin number 11, pin number 12 is connected to the LED yellow and LED blue for the digital power. And also for the analog, we connected the sensor to the A1 pin. Okay. So that's all for our demonstration, which means the end of our presentation. So that's all from us. Thank you.